Yeah, good morning, children. My first online classes, that was on Monday, was not a very good one because of the fact that where I am taking the class, this class in fact, is all empty and there is an echo. And I did not realize after recording it for 1 hour, I realized that there was a sound problem. And today, for your chemistry class, I have sorted out that sound problem. Now, our future classes, even the math classes, will not be as bad as it was the first class. So today, I'm here to teach chemistry, our very first chemistry class in class 10. And since our first chapter is periodic table, this periodic table you have already learned, or this chapter, the first portion of this chapter you have already learned in class 9. In class 9, you have learned from the periodic table part, you have learned about the very first Daubigner's triad, then after that Newton's law of octaves, then the most recent one that you can say is what was your Mendeleev periodic table also you have learned. But here ICSE syllabus in class 10, you have to learn only the last and the modern periodic table. The periodic table which is the most effective one, the most accepted table is periodic table, which is the modern periodic table, or we call it as long form of periodic table. So I am going to discuss with you today this long form of periodic table. Now how this long form of periodic table came into existence. Now, you know that we had accepted Mendeleev's periodic table as the ultimate periodic table, but then later we found that it had many defects, especially we found out that atomic numbers are better basis for categorizing different elements. In fact, the physical and chemical properties of these elements can be more suited. We can categorize them according to the atomic number rather than atomic weights. All the previous periodic tables, you know, they were based on atomic weight or atomic mass. And don't forget, atomic mass means the mass of an atom of that particular element. For example, a mass of sodium, how much does it weigh? What is the mass of oxygen? Or what is the mass of hydrogen? So as you can see that oxygen mass, atomic mass is considered as 16, meaning one atom of hydrogen and one atom of oxygen, if you really compare, oxygen is 16 times more heavier than hydrogen. But the modern atomic weight definition is something else. We compare it actually with 1/12 of one atom of carbon isotope 12. But then we found out, after Mosley's discovery, that the chemical and the physical properties of the element are more depending on their atomic number rather than atomic weight. So that is why now we have made the periodic table which is based on this theory, which is based on this assumption that the properties of the elements are more depending on atomic number than atomic weight. So that's why all the previous periodic table now have become absurd. So that is why now the most widely accepted periodic table is this periodic table which is in your syllabus, which we call as the long form of periodic table, or we call it as the modern periodic table. Now, along with this table, I also want to discuss with you a small revision of your class 9 chapter, language of chemistry. I think these two chapters, your language of chemistry and periodic table, they are complementing with each other. First, I will start with the periodic table, then maybe I will wind up with your language of chemistry. Here you are, periodic table. Your ICSE syllabus for periodic table is the first 3 period of the periodic table. Now when you say first period, now I don't have to explain to you what is a period and what is a group, because in Mendeleev periodic table also we had groups and periods. So those horizontal lines is what we call as period, and altogether in our modern periodic table we have 7 horizontal lines which we call as periods, so that we have altogether 7 periods. Whereas altogether this kind of vertical columns that we have are 18, and that is what we call as groups. Now group, older system as well as the new IUPAC system. Older system we have to name it as Roman 1, 1A, 1B, 1. Then again we have 2A, 2B, 3A, 3B. So likewise, you know, we had altogether 18 Roman numbering. That was the older system. But now according to the new IUPAC, IUPAC, don't forget, they are the organization which looks after all chemistry affairs all over the world. They are the one who decides about how a particular naming of a compound is to be done or an element is to be done. They are the one who formulate rules for chemistry. So according to them, now let me tell you what is that International Union of Pure and Applied Chemistry. They are the ones who decide. So they have decided now that this vertical line should not be numbered in this form as 1A, 1B, 2A, 2B. Rather, they should be numbered from 1 as a numeral. This form of numeral. So that means we have now the periodic table where the groups are categorized or named as 1, 2, 3, 4, like wise till 18. Since we have altogether 18 vertical lines, so we have 18 groups. This is something again which you know, especially about the groups and the period, because even Mendeleev periodic table had these groups and periods. Now, your syllabus mentions only first 3 periods. So, period 1, period 2 and period 3. Now, since our period 1 has altogether 2 elements, then your period 2 has altogether 8 elements, and period 3 also has 8 elements. So detailed studies, especially the atomic numbers and the changes in the properties of this total element. Now 8 at 16 plus 2 is what is 18. So the detailed study about these 18 elements of the first 3 periods of the periodic table is what your syllabus mentions. So you don't need to worry about now the other elements which comes beyond 18. You don't have to go to the 4th period, 5th, 6th, 7th, because altogether 7 periods are there. So that means detailed study about this first 3 periods is what we are going to discuss. In fact, yes, syllabus mentions this 3. But yes, you must have a general idea of everything, like how increases, decreases. We will not restrict ourselves to only 3 periods. We may go beyond that, or we may go beyond that. This 18 elements for like that will be in the next class as we discuss the different properties changes which will take place when you move in a group from top to bottom or from left to right in a period. But for that we have to see the whole periodic table. But you have to know this 18 elements, especially their atomic number. Now let me tell you, how are you going to remember these 18 elements? And do not forget, I am discussing this, and I said already that I am also going to discuss with you the language of chemistry. Many of you are struggling with formulas, especially symbols of different radicals, symbols of negative radical, positive radical is something again many of you are struggling with. You did not study that language of chemistry in class 9 properly. So that's why this may help you. I will not say 100%, but at least it will help you in some way. You will see that some of the valencies can be remembered if you also know what these 18 elements along with their atomic number. Now let us see how we are going to write these 18 elements in the order of their atomic number. Now I am going to help you in memorizing, in remembering this. Now the first element is hydrogen. Okay, rather than going and writing the second element, so I think I need a little bit of space. So let me write now the second period. Okay, since I am ending here, so that's why above that I will be writing helium. So it is hydrogen, helium, then you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now one more period to go. There you are. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now this is what is your first period, period 1. Okay, this is your period 1. This is your period 2. This is your period 3. Here, period 1, 2 elements as we mentioned. Period 2, 8 elements. If you count, 8 are there. 1, 2, 3, 4, 5, 6, 7, 8. And period 3 also 8. 1, 2, 3, 4, 5, 6, 7, 8. So altogether 18. So 8 plus 8 plus 2. And you should note that these elements are arranged in ascending order of their atomic number. Now, atomic number. as you know that modern periodic law is based on atomic number, as I already discussed about atomic number. Atomic number means number of electrons or the number of protons present in an atom. Like hydrogen has only one proton or one electron, so that's why it is placed 1. Now let me write hydrogen has an atomic number of 1. Okay, let me write here 1 atomic number. Serially, now look at this, how beautifully now you know the elements are arranged. So this is, I am not writing the serial number, even though you can see number 1, number 2, it looks like a serial number, but actually these numbers which I am writing are their atomic numbers. Hydrogen has 1 electron, 1 proton. Helium has 2 protons, 2 electrons. Then similarly, if I write lithium is 3, then this is what is 4, 5, 6, 7, 8, 9, 10. And this is what is 11, this one is 12, this is 13, this is 14, this is 15, 16, 17, 18. See, this looks like a serial number. I wrote all numbers, all natural numbers I started with number 1, natural number, and then I ended at 18. That means altogether there are 18 elements here. And don't forget, I have written it serially. I did not skip any numbers. All numbers are present from 1 to 18. But what happens actually is this number that I have written is not the serial number. You can consider it as serial number also, but they are in fact the atomic number. That means sulfur has atomic number of 16. Sulfur has 16 electrons. Argon has 18. Aluminum has 13. Sodium has 11. This is something which you people have to learn to write 18 elements in the same sequence. I know many of you can write in class 9, you have learned this. You can very easily, some of you have even memorized the order of this one. And those of you who have not, yeah, I'll give you a simple technique, not the usual conventional technique of memorizing. It will take a long time. A very, very unconventional method I will give you to remember these elements, 18 elements. Yeah, the way how I'm going to, whatever I'm going to tell you now may be making no sense, but then this is going to work. This will help you to remember these elements in the sequence of their atomic number. Here you go then. First period has 2. One is H and the other one is He. So remember the first period as if you are laughing. Yeah, ha ha. Oh, okay, laughing, ha ha. This H also is H, H also is. So ha ha means hydrogen and helium H. So both the elements which are present, which only 2 elements are present in period 1, and both of them are H. Okay, so remember already. Okay, remember period 1, what are the elements? Ha ha. H, hydrogen, the other H, helium. Next, second period. Now since 18 elements are there, that may make a little difficult. Now remember, again I am repeating that it makes no sense. I am just giving a sentence. You can make a more, maybe you will be able to make even more beautiful sentence, better sentence than mine. But here it is now, what that sentence is. I am going to write one sentence. Life be bored if class not offered free needles. Now if you tell me, sir, what this is? Life be bored. Okay, your life is very boring. If you like, life will be very, very boring. Yeah, life be bored. Yeah, I am writing if a little above, as you can see, because I is not there, but if I am writing so that a continuity of the sentence is maintained. Now please do not look for the grammar. Don't say that, yes sir, your grammar is wrong. I am not looking for a grammar here. I am not US sir. So that you can complain to US sir, but I am going for, since I am a science teacher, I'll go, my grammar is very, very bad. Here it is. Life be bored if class not offer free needle. Free needle? If you are given free needles in the class, you could have pricked your friend. Then it would have been very interesting. But then nobody is offering you free needle. So that's why the class is very, very boring. So now remember the sentence. Yeah, 5 times, 10 times if you tell, then I think this will remain in your mind. Life be bored if class not offered free needle. Now why this sentence is required? Because life, yes, lithium, first one. Be, beryllium. Yes, you can see beryllium. Bored, boron. As I said, this is only for continuity of the sentence, not this one. So now next, C is carbon. Then next, N, nitrogen, oxygen. Then you have fluorine, then neon. So A sentence, a meaningless sentence. Nonsense. This is a nonsense. But this will help you to remember actually the second period. So second period can be very easily remembered like this. Now, so once you have done this, again I am repeating, say it like how you had said in mathematics. Some people have curly brown hair turned from into black. So that is was magic in fact. Same way, if you say 5, 10 times with all your concentration, I think you'll be able to remember the elements in the sequence of the atomic number. Now we have one more period to go, last one, and that is sodium, magnesium, aluminum 1. There it is. I am going to write now. Namgyal. Okay, Namgyal Sips Clur. Okay, it's not making any sense. So what is that clur? Okay, now I'll just make a small continuation. Okay, between CLAR, I'll write E, so that becomes clear. Then to make a continuity, if you like, you can make a liquid also, clear liquid. Okay, so he's only drinking, sipping only clear liquid. Okay, Namgyal. Now, how will I remember Namgyal? Namgyal is a very, very popular Buddhist name, a Bhutanese name. Namgyal. I think we also have some hotels in Phuntsholling named Namgyal. So, Namgyal is a name of a person. Sometimes it can be a name of a boy, or it can be a name of a girl. Namgyal. Sips. I hope you know what is sips. Sipping means sipping of tea, taking. I think in Hindi you call it chuski lena. So sips. Yeah, sips clear liquid. Okay, she only sips clear liquid only. If something is mixed in it, she doesn't. This Namgyal doesn't take that. Alright, Namgyal sips clear or clear liquid. Here. Alright, now how it will help us? Now look at this. Na, yeah, sodium. Mg, there you are, magnesium, Al. So our friend Namgyal is helping us in remembering three elements. Namgyal, Na, MgL, Na, MgL. Sips is helping us with three more elements. Yeah. Silicon, here you are. Now phosphorus and sulfur. Yes, sulfur is another one. Then clear will help us with two elements. Cl is chlorine, you can see the 17th element, and finally the 18th element. So I wrote this liquid only for making some sense to the sentence. So that's why you don't need to just remember clear only. So Namgyal sips clear. That means now we have altogether 18 elements already memorized. So in the exam, if you need any of these elements, just remember the sentences. First then after that you will say light being bored, then after that Namgyal sips, you will say all 18 elements is what very, very clearly will come to you. Now, whatever may be this, if you are not memorized, you can also note it down in your copy, and then again, as I said, I'll say about 5-10 times, I think it will stay in your mind, it will stay in your brain. So this is how this 18 elements and their atomic number can be easily remembered. Now, once you have remembered this 18 elements, now what further now? If you know their atomic number, most of the property changes which are taking place in the periodic table is what you can easily find out. What property is changing as you go from left to right, there is a gradual increase or there is a decrease of certain properties. Like for example, we have to see altogether 16, 17 different physical as well as chemical properties. That I think in the next class, or else our video will go very, very lengthy today. So in the next class I'll be discussing, but as I said, around 16, 17 properties I am going to discuss. Similarly, as you go from top to bottom in a group, as you go down the group, then how same those 17 properties will change. That is what also we are going to see. But as I said, that is in the next class. Now in the beginning I said that I'll also be discussing with you something about language of chemistry. In that chapter, in class 9, we have learned about symbols and valences of different elements, positive radicals as well as also negative radicals. If you have not learned that, properly in class 9, you are really going to struggle in class 10. Almost every chapter, you have to write chemical formulas. Supposing somewhere you'll come across calcium carbonate, and if you do not know that the formula of calcium carbonate is CaCO3, or if you do not know that the formula for ammonium sulfate, if I have to write ammonium sulfate, then you have to write something like this, ammonium sulfate. And if you are not writing the valencies or that crisscross method, if you are not doing it properly, then it is as good as not writing, because according to ICSE analysis from the board, it says that if a formula is written wrong, or if an equation is not balanced, I think you have learned that balancing of equation also in chemistry, they are not going to give you any marks in the board exam. So that is why it is of very, very vital importance that you all should know that table. Now, in case if you don't know the table, what table I am talking about, I am going to give you that table there in the description, a download link. You can download that and then in the form of a PDF, and then you can study. So take your time. So it may take a week, maybe 10 days. But when you come to school, make sure that you are thorough with that. Every symbols and balances. Not many are there. I think it's very much manageable. Every year when the students are coming to class 10, I don't teach periodic table. I first start with that language of chemistry. I start with Valency table. First they will tell me, each and every student of the class will tell me the Valency table correctly. In fact, I used to call them in front of the board with the chalk in the hand. At least 3 of them will be there on the board, and then I'll tell them the symbols in the valency. In fact, I'll tell them a radical, positive or negative radical, and they are supposed to write the symbols and the valencies. Only when the whole class is thorough with that, then only I start teaching what is there in your syllabus in class 10. Because without that Valency table, it is not possible to learn chemistry. And don't forget those Valency tables, which you will find there in the description, and also a small, I think, screen is what I'm going to put it here in the video, is the heart of chemistry. Without heart, chemistry will start, it will start collapsing. In fact, it will die. So that's why if you really want to master chemistry, if you want to understand chemistry, because nobody likes chemistry. Chemistry is something which is very boring. But if you start understanding chemistry, then chemistry becomes very interesting. And yes, and chemistry becomes interesting if you know the Valency table, if you understand what you are writing. Everything will fall into place, everything will come in sequence, everything, so it starts making sense, because now what you are, or how you are learning chemistry, you are merging up reactions and going and writing in the exam. But if you understand chemistry, nothing can be more interesting than chemistry, I assure you that. So the first thing that I want is learn the Valency table. Now, among those Valency tables, yes, some of this is what you will find. You are going to find hydrogen. Okay, so as I said, the combination now between periodic table and just language of chemistry. Hydrogen you will find in the table at 2 places. Hydrogen is such a notorious element that you will find hydrogen in the positive, the upper part of the table, positive, as well as also you will find hydrogen in the lower part as negative, one as plus. This is what we call as hydrogen. This is what we call as hydride. Hydrogen, hydride. So if you check your Valency table, you will find both of these. Hydrogen on the upper part, positive radical, and hydride on the lower side, that is hydride in the negative radical. Now, if that is so, then hydrogen, Valency 1. How do you know? Yes, look at the configuration, electronic configuration. 1, since the outermost shell, don't forget Valency table as well as also your electronic configuration in atomic structure chapter. I think you have done in class 9, class 8 also you have done that. So now atomic number is 1 means, yes, electronic configuration is also 1. And valency of a particular element is taken out from the valence electron. Valence electron means electrons in the outermost cell. If the valence electron is 1, valency is 1. If it is 2, then it is 2, 3, 3, 4, 4. But if the valence electron is 5, then valency becomes 3. In fact, to be precise, it is -3. If outermost cell is 6, valency becomes -2. Then if the outermost cell is 7, it becomes -1. And if the outermost cell is 8, which is especially applicable for noble gases, then the valency becomes 0. Noble gases, they don't have any valency, they have 0 valencies. Now, I'm going to help you now with this valencies of this 18 elements. Hydrogen you are going to find in that valency table. So as you can see, valence electron is 1, it has a valency of 1. So both hydride as well as hydrogen and hydride, both of them has a valency of 1, except for the fact that this one is positive 1, the other one, as you can see, positive 1, negative 1. But when you are writing a formula, you are not much concerned about positive and negative. Just remember 1. 1 is fine. So you don't need to remember it as positive or negative. Now going to helium, you don't need that because since it is a noble gas, it doesn't show any valency. So even though outermost shell is 2, all others have 8, but then helium is also a noble gas, duplet. We call it as duplet configuration, outermost shell 8. So that's why it does not have any valencies. Valency is what is 0. Now going to lithium. Lithium is configuration is 2 and 1. As you can see again, outermost shell is 1. As the outermost shell is 1, so it has a valency of 1. Again, if you look at your valency table, so that table which is given below, lithium, if you see, valency is 1. Then beryllium is 2 and 2. So 2 means outermost shell is 2, valency is 2. This is 2 and 3. Then outermost shell is 3, so boron has a valency of 3. This is 2 and 4. Outermost shell is 4, so valency is 2. Sorry, valency is 4. Then if the outermost shell for this one is 2 and 5, if outermost shell is 5, valency is not 5. Valency is 3, negative 3, minus 3, 8. 5 minus 8 it is. 5 minus 8 is what is minus 3. So we can say, and in your valency table, what you are going to see? Lithium has lithium, beryllium has beryllium, boron has boron. Carbon you are not going to find. Carbon you are going to find below, negative radical you are going to find as carbide. You see carbide? Carbide is written as C minus 4. So carbide, valency of 4. Nitrogen you will not find again in the valency table. Nitrogen you are going to find there low side as nitride and minus 3 or 3 minus. By the way, this minus can be written anyway. You can write here or you can write there also. Yeah. Similarly, plus can be written front or back in the number. So you'll find this nitrogen as nitride in the valency table. Oxygen not as oxygen. You'll find it as oxide. So now see the configuration. 2, 6. As the outermost shell is 6, so you'll find oxygen is written 2 minus or minus 2. Outermost shell is 6, so 6 minus 8 is what is minus 2. Fluorine you will not see as fluorine, rather you will see it as fluoride. And fluoride, if you look at this, this is what is 2, 7. Outermost shell is 7, so valency is what is minus 1. So valency is minus 1. Fluoride is written as minus 1 like this, or 1 minus. And neon is 2 and 8, and outermost shell 8 means valency is 0. And you will not find this, none of this you are going to find it in your valency table. Next, sodium is 2, 8, 1, 11, so 2, 8 and 1. Outermost shell 1, that is why your sodium you are going to find as valency 1. You'll check the valency table, sodium valency 1. Magnesium 2, 8, 2. So outermost shell is 2, valency is 2. Aluminum is 2, 8, 3. So outermost shell is 3, so valency is 3. Silicon is 2, 8 and 2. Yes. 2, 8 and 4. So outermost shell is 4, silicon 4. Phosphorus has 2, 8, 5. Phosphorus you will not see in the valency table as phosphorus, you will see it in the form of phosphide. Phosphide, valency 3, minus 3. Then sulfur, you will find it in the valency table, lower side, negative radical as sulfide. Sulfur is sulfide, so it is 2, 8, 6. Outermost shell 6 means valency is minus 2. And similarly, chlorine is 2, 8, 7. Outermost shell is 7 means valency is minus 1. Chlorine is what you are going to see on the valency table as chloride. And as I said, these are noble gases. So they. Now, in addition to this, which you can remember, at least 18 of them, they are also there in your valency table. But in addition to this, all the positive and the negative radicals is what you need to memorize. Write down. Now, when you study it part by part. Monovalent. Monovalent means study first all which has valency 1. Maybe you will take 1 day to do that. There are just around 10, I am not very sure, maybe 10 elements, 10 radicals are there. Then next day you will learn the second one, third one, fourth one, then shift on to negative 1. Negative ones are little difficult because their formulas are a little complex, like a dichromate, Cr2O7, or acetate, CS3CO. All those what you are finding on the lower part of the table. Perfect that table. So next week when I am coming again, you will find that, especially maybe next week I will be discussing with you this periodic table, the remaining part of the periodic table. But I can assure you that other chapters, there are altogether 12 chapters. Different book has different numbers of chapters because in some book, more than one chapter are put together. So usually 12 chapters. Out of 12 chapters, you will find that 10 chapters will be requiring valency table. So again, I'm repeating, since I cannot test who has learned and who has not, but definitely in the future, if we have an interactive session, maybe an online or maybe on the physical class, if we take in the school, then definitely I want every one of you to be perfect with the Valency table. So especially like when I ask, if I call somebody and ask, hey, what is the valency of oxalate? Yeah, you have to do this. This is the valency. This is the symbol. This is the valency. What is nitride? What is carbide? What is ferrocyanide? You should be perfect with the symbol as well as also what is the valency. Then only you will be able to write the chemical formulas properly and nicely. Yes, if a little bit of revision is required for how to write crisscross method in class 9, where bracket is required, where bracket is, sometimes we are not giving bracket, sometimes we are not giving bracket. Hopefully, I think you all have understood in class 9. In case if you have not, then maybe in future classes we'll be discussing. So in the next class, I'll be discussing with you for the second part of this periodic table. So I have today only discussed just the writing of these 18 elements, but then in the next class we'll have a further discussion of this one. Yeah, thank you very much and bye bye. See you on Monday in the maths class.